Imagine floating in the darkness between star systems, far from any sun, in a place that appears to be nothing but empty black silence. Yet this space is far from empty. Stretching across unimaginable distances, enormous clouds of gas and dust drift through our galaxy, weaving together an invisible fabric that connects every star, every planet, and every corner of the Milky Way. This is the interstellar medium, and it is one of the most fascinating and overlooked environments in all of cosmic science. These vast clouds span hundreds of light years, carrying the raw materials of creation itself. They whisper stories of ancient stellar explosions, of matter recycled across billions of years. Understanding this hidden ocean between the stars is not just an exercise in curiosity. It is the foundation for understanding how galaxies live, breathe, and evolve. So let us begin our journey outward, past our solar system, into the extraordinary universe that waits beyond. Now that we understand the sheer scale of the interstellar medium, let us look more closely at what it is actually made of. Despite appearing empty to the naked eye, this vast cosmic expanse is filled with a rich mixture of gas and dust. The most abundant element is hydrogen, making up roughly 75% of all matter in the interstellar medium. Helium follows closely behind, accounting for most of the remaining percentage. Together, these two gases form the foundational raw material of the universe. But the story does not stop there. Scattered throughout this gaseous ocean are tiny cosmic dust particles, microscopic grains made of carbon, silicates, and ice. These particles may be small, but their influence is enormous. They absorb and scatter starlight, shape the temperature of surrounding regions, and serve as surfaces where complex molecules can form. Far from being empty voids, these ingredients are the universe's own recipe for creation, quietly waiting to build something extraordinary. These vast clouds of gas and dust are far more than passive scenery drifting through the cosmos. They are active architects of the galaxy itself, driving some of the most powerful processes in cosmic history. When regions within a molecular cloud grow dense enough, gravity takes over, pulling material inward until temperatures soar and nuclear fusion ignites. A new star is born. This cycle has repeated billions of times across the Milky Way, seeding the galaxy with countless suns and planetary systems. But the influence does not stop there. These enormous clouds also help define the structure of spiral arms, the sweeping curved features that give our galaxy its iconic shape. As stars form along these arms, they illuminate and compress surrounding gas, triggering even more stellar births in a cascading chain reaction. The interstellar medium is not empty silence. It is a dynamic, ever-evolving engine powering the continuous transformation of our galaxy across billions of years. Now let us bring our focus closer to home, to our very own solar system. While the interstellar medium shapes galaxies and births stars, our sun has created something remarkable right here in our cosmic neighborhood. It is called the heliosphere, a vast magnetic bubble generated by the sun that stretches far beyond the orbit of Pluto, essentially wrapping our entire solar system in an invisible protective shell. This enormous structure is not just an interesting scientific curiosity. It serves as a critical natural shield, deflecting and absorbing harmful cosmic radiation that streams in relentlessly from deep space. Without it, Earth and every other planet in our solar system would be constantly bombarded by intense high-energy particles originating from distant supernovae and other violent cosmic events. Think of the heliosphere as our solar system's personal force field, quietly working around the clock to make life as we know it possible on our small blue planet. At the heart of the heliosphere is the solar wind, a constant stream of charged particles, primarily electrons and protons, flowing outward from the sun at speeds of roughly 400 kilometers per second. This relentless outflow pushes against the interstellar medium, inflating a massive protective bubble that stretches far beyond the orbit of Neptune, extending over 100 astronomical units from the sun. The boundary where solar wind finally loses its battle against interstellar pressure is called the heliopause. Inside this boundary, harmful galactic cosmic rays are deflected or slowed before reaching Earth. Without this shield, the consequences would be catastrophic. Intense radiation would strip away our atmosphere over time, bombard living cells with lethal doses of cosmic rays, and disrupt the magnetic conditions that support life as we know it. The heliosphere is not merely a scientific curiosity. It is an invisible guardian, quietly standing between life on Earth and the deadly forces of deep space. Now that we understand the protective bubble surrounding our solar system, let us turn our gaze outward toward something truly thrilling. Beyond the heliosphere lies the vast interstellar medium we explored earlier, and somewhere through that cosmic ocean sits our nearest stellar neighbor, the Alpha Centauri system. Located roughly 4.37 light-years away, Alpha Centauri represents the closest star system to our own sun. To put that in perspective, 1 light-year equals approximately 5.88 trillion miles. That is an almost incomprehensible distance. Yet in cosmic terms, Alpha Centauri is practically next door. Scientists and space enthusiasts alike consider this system the most realistic destination for future interstellar exploration. It is close enough to study in meaningful detail, complex enough to be scientifically fascinating, and potentially harbors conditions that could support life. For these reasons, Alpha Centauri has become the crown jewel of humanity's interstellar ambitions and dreams. Now that we know Alpha Centauri is our closest stellar neighbor, let's explore what this system actually contains. Alpha Centauri is not a single star, but a trio. Alpha Centauri. A is the largest, closely resembling our own sun in size and temperature. Alpha Centauri B is slightly smaller and cooler, yet still a stable sun-like star. Together, these two orbit each other in a graceful cosmic dance. Then there is Proxima Centauri, a small red dwarf sitting about 1/5 of a light-year away from the pair, making it technically the closest individual star to Earth at roughly 4.24 light-years. But what truly electrified the scientific community was the discovery of Proxima b in 2016. This rocky exoplanet orbits within Proxima Centauri's habitable zone, meaning liquid water could theoretically exist on its surface. That single possibility has ignited passionate debates about whether life might exist just next door in cosmic terms. So just how far away is 4.37 light-years? Let's put that into perspective. 1 light-year alone equals roughly 5.88 trillion miles. Multiply that by 4.37, and the number becomes almost incomprehensible to the human mind. Now consider our fastest spacecraft ever launched. NASA's Voyager 1, currently the most distant human-made object in space, travels at roughly 35,000 miles per hour. Impressive by any earthly standard. But at that speed, reaching Alpha Centauri would take approximately 73,000 years. That is longer than all of recorded human civilization, multiplied many times over. Even our most advanced modern probes would barely improve that timeline. The distance isn't just large, it's humbling. It forces us to confront a hard truth. With the technology we have today, the stars remain frustratingly, almost cruelly, out of reach. But that realization, rather than discouraging us, has pushed brilliant minds to think far beyond conventional limits. So if conventional spacecraft simply cannot make the journey in any reasonable human time frame, the question becomes, is there another way? That question is exactly what inspired one of the most daring space exploration concepts ever proposed, breakthrough starshot. Announced in 2016 and backed by renowned physicist Stephen Hawking, investor Yuri Milner, and Facebook founder Mark Zuckerberg, breakthrough starshot represents a genuine attempt to solve the interstellar distance problem. The idea is both elegant and radical. Instead of sending a massive traditional spacecraft, the initiative proposes launching incredibly tiny spacecraft called nanocrafts. These miniature probes, no larger than a postage stamp, would be propelled not by rocket fuel, but by powerful laser beams fired from Earth. The goal is breathtaking. Accelerate these nanocrafts to speeds reaching up to 20% of the speed of light. At that velocity, Alpha Centauri suddenly transforms from an impossible destination into a reachable one within a human lifetime. So how exactly does Breakthrough Starshot plan to make this incredible journey happen? The answer lies in a revolutionary propulsion concept unlike anything ever built before. The system relies on an enormous ground-based laser array, essentially thousands of individual lasers working together to generate a single, extraordinarily powerful beam of light. This beam would be directed at a tiny spacecraft equipped with an ultra-thin reflective sail, sometimes called a light sail. When that concentrated light strikes the sail, it creates enough pressure to accelerate the nanocraft to staggering speeds. We are talking about reaching up to 20% the speed of light within just a few minutes of launch. To put that in perspective, conventional rockets would take tens of thousands of years to cover the same distance. With this laser-driven approach, the travel time to Alpha Centauri shrinks dramatically to approximately 20 years. That is within a human lifetime, transforming what once seemed like pure science fiction into a genuinely achievable scientific mission worth pursuing. As thrilling as breakthrough starshot sounds, the engineering challenges standing between concept and reality are staggering. First, the nanocraft must survive the laser launch itself, where intense beams of light exert enormous pressure on the sail without tearing it apart or overheating the delicate electronics on board. Even a tiny misalignment could send the probe spinning off course into the void. Then comes the journey. Over 20 years of travel, the nanocraft will be bombarded by cosmic radiation and high-speed interstellar dust particles. At 20% the speed of light, even a microscopic grain of dust hits with the force of a small explosion. Finally, transmitting data back across 4.37 light-years requires an incredibly powerful and precisely aimed communication system packed into something barely larger than a postage stamp. These are not small problems. They represent some of the most complex scientific and engineering puzzles humanity has ever attempted to solve. Everything we have explored in this journey tells a single, breathtaking story about humanity's place in the cosmos. The interstellar medium is not empty darkness, but a living canvas where stars are born and galaxies evolve. Our heliosphere stands as a silent guardian, shielding life on Earth from the relentless fury of deep space radiation. Alpha Centauri beckons as our nearest cosmic neighbor, whispering possibilities of worlds we have never seen. And breakthrough starshot dares to transform that whisper into a plan. Together, these ideas represent something profound. They show a species that refuses to accept limits, a civilization learning to read the universe and respond with curiosity rather than fear. We are still early in this journey, perhaps only taking our very first steps. But every great voyage begins with imagination. The stars are not unreachable destinations, they are invitations, and humanity is finally beginning to answer. Remember, what feels like an enormous journey, from our sun's outer boundary to the nearest star system, is in reality but a tiny step within the Milky Way. If you want to keep exploring the universe and uncover what lies beyond, hit subscribe and check out my latest video here now.